The Amazing Yeti.
The Amazing Yeti.
The Amazing Yeti.
Yeah, the Yeti. Pardon me while I have a sip of drink here.
Oh, yeah, go ahead.
Oh, that's cold.
I would assume so.
It is very good. Quite tasty. And this has been sitting here about an hour, hasn't it?
Yeah.
Been sitting here a long time. Oh, it's so cold. That should not be cold an hour later, should it?
No, it shouldn't.
No.
My drink. Yep. It should be. Something amazing. We discovered it at the ACE show.
Ooh,
Say Yeti again.
Yeti.
Can you read out what it says on the bottom of this thing?
Ooh, Yeti.
You see Yeti on there?
Oh, yeah.
Yeti is what abominable snowman's called Yeti, isn't it? You know, that guy that lives
Yeah.
on the mountain.
Oh, yeah.
You know, the one that kind of looks like Norg,
Mm.
the furry thing that swings to the ice up on top of the mountains. A Yeti. Yeah. You know, in hardware science, everybody say, "Hey, it's hardware science."
Hey, it's
hardware
hardware
Oh,
science.
there we go. Yeah, here we are. Normally we try to make things, right?
Yes, we do.
So we thought we'd start doing a new thing called tearing it apart and find out how it works.
Okay.
Have you ever done
Oh,
that?
that's
Tearing
fun.
things up,
Yes.
tear them up, see what's going on.
Mm-hmm.
So it posed to me, I had a question because they gave me one of these Yeti cup holders, soft drink or beer can holders, and how long it stayed cold.
Mm-hmm.
And then I put a hot drink in one, and it stayed hot for a long time. I thought, boy, I wonder what's going on inside this thing that is keeping this soft drink so cold so long. So I'm gonna put that over there. And I looked down inside and I thought, well, that's disappointing. Well, it doesn't look like anything, does it?
Oh,
Anything
well,
going on?
no. Doesn't look like
It's
anything's
like an
going
empty
on.
can.
Mm-hmm.
And
It's
it's nice and smooth and everything, metal. It's solid. And I thought, I don't hear anything going on inside. I said, how does this thing keep that cold? I mean, I've had things that keep
Yeah.
stuff cold and hot
Oh,
before,
yeah.
like cups, styrofoam cups and all that stuff. But this thing's crazy. It's cold. So being the wizard, what do you think we did?
Oh, you cut it right open.
I did. That's the
You
way I am.
right.
That's what we do here, right?
That's what we do.
This new thing. Instead of building things, we're going to tear it apart. So Ada,
Yes.
there's a Yeti that we cut in half. Right there. Did you pick
This
that
one?
up? Yes. Oh my gosh. Well, what do you know? Tell me what you know. Forget the tape. I just put that on there to hold it together.
Okay.
See, tell me what you notice and point it towards the camera so they can see.
Okay, sorry.
That's it. Don't worry about it. Is a scientific term.
Okay, so I see like 3 different parts to it,
Oh,
I
there's
think.
more parts?
Yeah, so there's there's the bottom.
The bottom.
Okay, and
yellow
then
cover.
there's like what we would see the outside,
outside,
you
and then
know,
you've
and then
got
there's the inner layer of it.
Oh, so it's layered.
Yeah.
So I see one layer of metal,
Mm-hmm.
and then another layer of metal, and what's in between the 2 layers?
Nothing.
Nothing. Well, nothing's in there. Well, air now, obviously, right?
Yeah.
Yeah. There you go. Well, actually, to give you a hint on how this works, you remember one of the first things we did in hardware science about heat conduction?
Oh, yes.
And you explain
Yeah.
what we did with that thing, Al.
Okay, so we
Hold it
put-
so the camera can
yeah.
see that right there. What is that? Oh, I'll point out the parts. You tell me.
Okay.
I got this is right here.
Oh, that's the where we hold it
The
at.
handle, and there's a
The
support
handle,
right
yeah,
there.
yeah.
And right there's the
main conductor.
hub.
The
Call it
hub.
the hub.
The hub.
And these are called spikes or
Spikes, yeah.
rods.
Mhm.
Yeah. Now tell me about the rods.
Okay, so I know that this one's copper.
Yeah.
This this aluminum.
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 There's different metals.
Yeah, different metals. Yeah,
Okay, so what did we do? We got a hub.
a hub.
I like
Yep.
saying that. Say hub.
Hub.
Hub. We got a hub with different types of metals sticking off like that, right?
Yep.
And what did we do with it?
Well, we had this flame.
Okay, we had a
and
flame.
we
Yeah.
we put it over the hub.
The
we
hub,
put the hub over the flame,
Flame on the flame.
and we put wax on the
Okay.
end of each
Oh,
of the
you
metals.
put wax on each one of those,
Yes.
right?
Yes.
And what happened to the wax as you heated it up?
Well, they started melting, but they didn't melt at the same time. They melted at different times. And I believe the copper was the one to melt the
Okay,
wax
well,
first.
we'll try that one. And they melt at different times because they conduct heat
Differently, at a different speed.
At
Yeah.
different rate.
Yeah.
Well, and that's this is the reason I got this out. What would happen now if we took that same piece of wax that we put on here,
Mm-hmm.
and instead of putting it on the metal, I would put it right here between 2 pieces, right out in the air.
I don't know if it would melt.
if we could
Yeah.
support a piece of wax right there.
Yeah.
And we heated it up. And this one would melt at one time, and then this
Yeah.
one might melt next. That's brass, and then the aluminum and the stainless steel and the iron. They'd all melt at different rates.
Yeah, it would.
And this one that's suspended in between them,
Yeah.
would it melt very fast, do you think?
No, I don't think so.
It might not even melt at all,
Yeah, I don't think it would.
because there's no way for the heat to be conducted to it, right?
Yeah.
It's kind of safe out there. Now, how does that, what I just described, apply to this?
Well, it's hard for the heat or cold air to move between one metal to the other.
Okay, well, we got to talk about
Okay.
physics. Did you know it's only heat, no cold?
It's only heat. Okay.
Only heat. It's
Oh,
either
only
heat coming or going.
Okay. So
When it's coming
yeah.
towards you, I'm hot. When the heat's leaving you, I'm cold.
cold, yeah.
That's right. So we're not talking about cold moving, it's heat that moves.
Okay.
Yeah,
Heat
sure.
that's moving.
Yeah. So if that gap provides a barrier or a place where the heat can't go,
Yeah.
you know, if I'm trying to keep something cold, the heat won't come in from the outside try something cold, and warm up my Coke, or vice versa, something hot, the heat won't go
Yep.
out.
Okay.
But these Yeti folks are there as nuts. They weren't satisfied with just that. They really wanted to keep all the heat in or out. So I asked them, we were at the ACE show, and we went up to the to the Yeti booth and asked them to explain what's going on inside this simple little cup. You wouldn't think there'd be much going on, would you?
I wouldn't know.
No, I know about the heat not being able to jump the gap there. So let's run that video and talk to the Yeti guy.
Bob, I'm Marshall Ward. I work with Yeti Coolers. We're based out of Austin, Texas. So one of the products that we have here that we produce and build, there's a lot of science inside, is our Yeti Ramblers. So we've got a bunch of different Yeti Ramblers. We got some different sizes, different colors, but it's what inside of these cups that really makes a lot of difference in terms of keeping things cold or even keeping things hot. So in this cup, we actually have two different walls. There's an outside wall and there's an inside wall. And the reason why there's two different walls is the air inside there, we've actually sucked all the air out. So it's called vacuum insulation. The reason why it's called vacuum insulation is because we have sucked the air out. The reason why vacuum insulation is so great is because there's not as many air molecules inside between those two walls. Air molecules actually is what causes heat transfer. So if you can suck all those molecules out, whatever's on the outside is not going to affect whatever's on the inside. And that makes whatever's inside stay colder longer. So your nice cold Coca-Cola Classic, it's going to be perfect in there, which is perfect since we're in Atlanta, home of Coca-Cola, right? But we also have a second piece that's inside this cup that makes a lot of difference, which is, we call it a radiant barrier. What it is a line, we've lined it with copper. So I don't know if we can see it too well on this particular piece, but since the inside is lined with copper, what that copper does is actually kind of reflects any radiation that might be coming through the outside of that cup. The reason why we want to reflect that radiation, because a lot of folks, especially folks who love their Yeti coolers, love to be outdoors. They love to camp, they love to hike, love to fish, you name it. So we're going to be using these cups outside. So the sun and all the radiation that comes off that sun is going to be beating down in this cup all the time during the day. And so we don't want any of the sunlight and the radiation, the UV rays coming off of that to affect anything inside here. So we can set this down in the 100-degree heat, and the ice that you have inside and whatever you have inside is going to stay cold and not be affected by the sun rays coming down.
One question.
Yeah.
How does this differ from other kinds of cooler cups?
Other types of cups. So vacuum insulation is in a lot of different cups out there. One of the reasons why Yeti is special in particular is we have this little piece at the bottom. So it's kind of been cut, but you can see it, just this dimple right here is the technical term for it, believe it or not, is actually called the gitter. And the reason why we call it the gitter is because it actually gets any extra air molecules that we haven't completely vacuumed out. Because we are doing the vacuum sealing on planet Earth, we can never get 100% vacuum. There's always going to be at least 0.001% of air molecules still bouncing around. That getter, once the air molecules kind of bounce to the bottom, they'll end up finding this getter, and this piece will actually kind of, it'll act as a magnet for those air molecules, which is interesting because that means that the cup is going to perform better the longer you use it, because that's the longer that getter goes to work, the more air molecules it'll be able to trap. The other piece that's very different between our cups and other cups is that radiant barrier. The copper lining that we use is not going to be found in other products. Not everyone uses copper. One of the reasons why is because copper is expensive. But we feel the need, and we know the value of that copper and the performance that it provides, that we include it on every single piece and every single cup that we make, because it is such a crucial piece of keeping your drink cold.